Well, thank you very much for having me here today. I'm happy to talk about uh, yeah, my work and what I plan to send to the moon with the Moonbound book. And my topic is Greater Earth, which is my platform, as you may know. And just a few things I'd like to point out. It's kind of obvious, but if you see how I write the word Earth, I emphasize the art part of it. And I think actually, if we would think about making Earth an artwork, we would solve a lot of humanity's problems. So that's why I emphasize that. And also the logo that you see on my jacket here, but I also use on my thing, which is GE and a symbol. It sort of looks like Geo, but it actually stands for Greater Earth. And that symbol is the Greek astronomical symbol for planet Earth. And I really believe in art and stuff. Symbols are very important for conveying information, even it's very subtle. So people see this and think geo, and actually that's what we're talking about. Anyway, this is my work that I've submitted to the Moonbound book. It's also Greater Earth, and Greater Earth to me is very important and very important that it's going to be launched to the moon. And actually, Greater Earth is a new perception of our planet, which is based on celestial mechanics and physics. And it's also an interdependent dynamic system responsible for life on Earth. And on a cultural level, it's an opportunity to create global prosperity and energy security with the hope that if we could achieve peace off Earth, we could have peace with Earth and peace on Earth. And I will explain how I see that happening. Well, my story goes back over 70 years ago. And this picture here is my first actually encounter with space. And these two pictures are of the same rocket, the Redstone rocket. And my father is in that picture on the left. He was he was part of this the Redstone tactical rocket team when he was in the military, and he made liquid oxygen for the Redstone rocket. And in 1959, he retired from the military and moved the family to Florida and near Cape Canaveral and Kennedy Space Center. And he actually made liquid oxygen for the Jupiter rocket, which was the same actual missile that took Alan Shepard into space, America's first astronaut. And so this this picture has actually impregnated me about humanity's choices it has to make. We could use our technology to destroy us, or we could use our technology to go into the cosmos and make things better on Earth. So that's very important to me, and that has actually impregnated my work ever since. So I grew up at the Space Center. It was really a great time. A lot of rockets were going off. Everybody was going to the moon. The whole community was really excited. And I actually worked at the Space Center during the Apollo project as a university student in the summers of 67 and 68. And I was there when Apollo 11 took off on July 16, 1969, with thousands of other people standing there. And this was a really fantastic experience for someone. And whoops, I went the wrong way. Here we go. And later on, when I was developing my art career, uh, I moved to Switzerland in the meantime, and I thought, how can I put space into my art? And so space is a very big thing, and I came up with a very big idea. And my idea was to put a circle in the sky to celebrate the transition to the new millennium in the year 2000. So I thought a circle symbolizing global unity and hope and peace would be something that the world would appreciate happening, because there were going to be all kinds of events and parties at that particular time. Well, oops, I'm sorry, wrong button here. But I did not have an engineering background, but I did have some visioneering, and I started making concept drawings about how one could actually make a circle in the sky, an orbital sculpture. And so I thought maybe you'd take a space shuttle and put a big roll of mylar on it, and it would do a loop in space, and that would make the object, or you could have astronauts sewing it together. And actually, about that time in Switzerland, coincidentally, there was a trade fair, a space trade fair called Space Commerce. And I asked the organizers, I am this artist, I have this idea about doing some art in space, and could I present my idea at your conference? And they go, well, if you're willing to pay a fee and have a stand in the conference and make a nice display, then of course you're welcome. And so I signed up, and I was there with all of the big players in the space community, and my little stand was in the corner. And actually, right next to me was a company called Contraves, which was a Swiss company that I had not heard of before, but it was just 10 kilometers from where I live. But they were right next to me on the stand, and they were exhibiting a technology for inflatable space rigidized structures. And I go, aha, now that could be very useful for space sculptures. And so I talked to them, and they put me in contact with their head of research and development, Dr. Marco Bernasconi, the fellow with the tie there. And the company gave him the permission to work as a consultant for me on my project. And we got along very good. And he thought what I was doing was pretty exciting, how to use space technology. And very quickly after that, he defined what it would take to use this technology to make the ring, the circle in the sky that I wanted to do it. And the object on the right is a torus with a diameter of 1 kilometer and had a weight of 19 tons. And this would do it. It would make a circle in the sky about a quarter the size of the moon. So we go, that's very cool, but it's actually too big of a project to start off. And so this object on the left, the Contravis had been built that as a test object. And I go, look, why don't we take this and use this object as kind of a prototype for a smaller sculpture to see how it works? And actually, I went back to space commerce in 1988 with this idea. And actually, interesting, the Soviet Union also had a stand there. Globkosmos, representing the Soviet Union space program, they had a stand there. And well, we made a deal very quickly, and that we signed a letter of agreement that they would actually fly the space, we call it the Space Peace Sculpture, to the Mir station. And we'd be responsible for the development of the project, and they would be responsible for launching and deploying the sculpture. So this is very, very exciting. And we got a lot of publicity about it. And this is a kind of a conceptual idea of what it would look like. We had the symbol of the Earth, based on this torus that was on display there from Contravis. It was covered with the words of peace in all the world's language, and it had the cross in the center. On the right is a diagram that was sent to us from the Globkosmos about how we could package it and send it to the Mir station. Well, this is very cool, and not only was I showing this in the space community, but it got a lot of publicity and enabled me to actually have exhibits of this at the prestigious Art Fair in Basel in 87, 88, and 89. And this gave the project a lot of momentum because we were out trying to raise funds for the project. And what actually happened is that Contravis, for some reason, decided that they did not want us to use their technology anymore for this project. So they withdrew their support from the project. So this was a shock to me and Dr. Bernasconi, and we actually went to Moscow to meet our partners there, and we explained the situation, and they said, look, don't worry, we have our own inflatable technology. And so they showed me the picture on the left, which was two inflatable antennas that they deployed off a Progress capsule. And on the right, they made this kind of sketch of how they would actually deploy the Space Peace Sculpture from the Mir station and make a video of it. So we were actually back in business. And a little bit later, they sent me this picture on the left that they made their own version of the Space Peace Sculpture, and they sent it to me. And that's the picture on the right. That's the container it came in. And actually, I went back to Space Commerce again in 1990, and there we actually deployed the Space Peace Sculpture in the Space Commerce there, and actually we inflated it and suspended it from the ceiling. So this is very cool. So we were really working hard to make this happen. The idea was to have this to be used to celebrate the 1992 International Space Year, and that was our goal. And things were going forward. However, the Soviet Union crashed in 1991. And that put our whole project on hold because we didn't know who to talk to or what was going to happen. And so that was another big shock to the thing that was pretty well developed. And so that's it. we didn't know what was going to happen, but what happened was that I was contacted through a German space company that the Russians were still very interested in doing something with me in space. And so that's how the cosmic dancer happened. So they said, if you have something smaller that could happen in a short period of time, then let's do it. So the cosmic dancer happened in 1993. And because of that, I was able to convince ESA to fly the first art exhibition in Earth orbit, ours at Astra, which was flown on Euromir 95. And so that was very cool. Uh, at that time, Dr. Berlusconi and I, we were doing some philosophical work, and we came up with this concept called the space option that because a lot of people were asking, why do you put art in space? And we had to actually explain the whole idea of why space is important to people. And we published an article in Space News called Choosing a Space Age or a Stone Age, how space was really definitely important. That's the first time we actually mentioned the concept of greater Earth in public. And so greater Earth is a concept of, it's actually the true dimensions of our planet if you look at it, because we always think of our planet as defined by the atmosphere around it, but in a cosmic way, it has a sphere of influence defined by its gravity. And this is based on a scientific concept called the Smith sphere. And Earth's gravitational influence extends out 1.5 million kilometers, creating a sphere of 3 million kilometers. And inside the sphere, you have the moon, you have occasional asteroids passing through, and you also have 55,000 times the amount of solar energy passing through the sphere than actually falls on the surface of Earth. And solar energy is actually very important. Also defined by this from celestial mechanics, you have the Lagrange points 1 and 2. Lagrange point 1 is between the Earth and the Sun, and that's a really good place to put scientific instruments or satellites, and L2 is as good. And so actually, the James Webb Telescope is located at L2. It's looking out into the cosmos. And at L1, there's several satellites there, but one very interesting is called Discover, which is a NASA satellite that's taking a snapshot of Earth every 5 minutes or so. And this is a picture taken from 1.5 million kilometers from Earth at the Earth with the moon passing in front of it. I think that's very, very cool. So this is taken from L1. So it's like our satellites are looking back on us. I find this very cool. Anyway, I'm very interested in space solar power because we have energy problem on Earth. It's gotten much worse since then, and the concept has been around for about 40 years. And just to explain it very briefly, you put a very large satellite in orbit, maybe several kilometers in diameter. It captures solar power and converts us into microwaves, and it beams us down to a receiving antenna or a rectenna on Earth. And in this illustration here, you would get about 1 gigawatt of power on Earth. And now 1 gigawatt of power is very similar to what a nuclear power plant, most nuclear power plants produce today. Well, that's very good, except we need to have any feasible impact on solving Earth's energy issues and climate issues. We need probably hundreds, if not thousands, of such satellites. And that's a problem because to launch one of these, and everybody's hoping that Starship is going to be operational soon, or Long March 9 from China, which has similar capabilities. But you see here, these are 4 different space solar power satellite concepts. And to get one of these into greater and to geostationary orbit, you would need, even in the most optimized one from Cassiopeia from the United Kingdom, you would need about 119 launches of Starship to get this into geostationary. So this is, first off, a very big logistical problem, and maybe SpaceX doesn't want to do it because they have their own program. And it's also an environmental problem because all of those launches, and like if you launch even 100 of Cassiopeias, this would be like 12,000 launches. So it's a very big problem. So the idea is to go to the moon. And as you see, I submitted a project to ESA, had a call for ideas for clean energy for new ideas for clean energy from space. And so we recycled or repurposed the space piece sculpture. We covered it with with photovoltaics and added a transmission antenna to it. I mean, it's much bigger than that would have been. And actually, our project was selected, and it was one of the 13 ideas that was funded by the European Space Agency, just to see. And our concept was if we wanted to go to the moon and set up manufacturing facilities on the moon and create a solar power satellite to power lunar operations. And if that was successful, we could use that and scale it up to make solar power satellite components for Earth. Well, the project was completed. The feasibility was completed in 2023, and that's my team there. My company is called Astrostrom, and we did this. And actually, ESA was very, very happy with the study, and they published it on their website. And we're still working on it because we think out of all the different space solar power concepts which are being developed all over the world right now. There's quite a few companies and interests and countries actually too developing this idea. So we really think this is probably the best idea. And one of the results of our study was that we identified three key technologies. And one of those was we would make photovoltaics on the moon with a technology called monograin layer solar sails, which is being developed by the Tallinn University of Technology in Estonia. And they would use actually lunar materials to synthesize pyrite, and it makes actually a photovoltaic thing. And this is much better than silicone. To make silicone wafers from lunar materials is super, super, super complicated because you need to have incredible purities and a big industrial process to do it. So this actually is quite a simple technology. The other thing is using lunar basalt for making structures, and basalt can be either sintered to make construction blocks, or it can be turned into a very a fiber that can be used to make components for our solar power satellite. That's the other thing. And basalt is very, very common on the moon. And the other idea is how to get our objects from the surface of the moon into space. We decided the lunar space elevator was the most elegant idea, and the lunar space elevator could be built with materials existing today, whereas the Earth space elevator is still waiting for some exotic nanotechnology. But the lunar space elevator, there's several studies have shown that it could be built today, and this would be very cool. And if it would happen, we would create the cislunar transportation and economic system. You would have like the Panama Canal between Earth and the moon, and with the elevator in the middle, and you would have things going both places, and you would have the multi-trillion energy market on Earth actually financing this whole thing. So you actually have a business case for going to the moon, which none of the moon projects at the moment, including Artemis, they don't really have a business case. They have a case they want to continue exploration, but they don't really have a way they want to pay for it. But we think the multi-trillion energy market on Earth would be the key to do that. And if that would happen, this would result in other economic activity. You would have tourism, habitat, sports, more resources for the moon, and this would actually help humanity to open up the whole solar system if this would happen. Well, another thing in our study, how to do this, we propose to set up what we call the Greater Earth Energy Organization. And this has a lot of advantages because if one country or one company would go and try to do this, you're going to have conflict. And so the Greater Earth Energy Organization is a proposal for an autonomous multinational treaty organization of nation stakeholders, and they would all share a mutual interest to have energy security while meeting their climate goals. And this idea would de-risk the initial investment, which is very, very substantial, of course, to set up operations on the moon, and would also de-risk the geopolitical conflict because these nations would have to work together to make this happen. So the idea is modeled on several space and energy organizations that existed today. So the idea and the concept is not totally out of it. And so we've been studying these different ideas to model how the Greater Earth Energy Organization could indeed be set up. And actually, if this would happen, we would bring clean energy from the moon to Earth. We would actually have, in a cooperative way, we would have peace off Earth, and this would stimulate peace with Earth because we could clean up our environment, and then hopefully working together would result in peace on Earth. So that's the vision that we have for this, and looking forward to launching Greater Earth to the Moon with the Moonbound book and also the GEO later this year. So Thank you very much for your attention. And if you have any questions, please ask.